everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem solve. D power 4 minus 1 into y equals to cos x into cos hx. Firstly, let's find the order and degree of the given differential equation. Identify the highest derivative here. D power 4 is the highest derivative, so our order will be 4. And highest power of the highest derivative is a degree. Degree is 1. Or just write the given differential equation as d power 4y minus y equals to cos x cos hx, right? D power 4 into y, d power 4y minus 1 into y is y equals to RHS part. Now, we know that d is a differential operator. Then d square will be d square by dx square. And d power cube or d cube is d cube by dx cube. And d power 4 is d power 4 by dx power 4. So we can write our equation as d power 4 y by dx power 4 minus y equals to cos x into cos hx. Right? Here d power 4 y by dx power 4 is the highest derivative. So our order will be 4 and highest power of the highest derivative is a degree. Degree is 1. Right? Now coming to the problem. Given differential equation, d power 4 minus 1 into y equals to cos x into cos hx, which is an operator form. F of d into y equals to q, where f of d equals to d power 4 minus 1 and q equals to cos x into cos hx. Right? Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function, yp is a particular integral. We'll find complementary function using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by putting RHS to 0, we'll get the homogeneous equation of the given non-homogeneous equation. And we'll find yp is in 1 by f of d into q. Now let's find yc and yp. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d power 4 minus 1, right? Let's replace differential operator by m, so that we'll get f of m equals to m power 4 minus 1. Then we'll get auxiliary equation m power 4 minus 1 equals to 0. Right? Now, let's write m power 4 as m square whole square. We know that a power m whole power n equals to a power m into n. Then a power m into n. M power 2 into 2 can be written as m square whole square. Right? We can write m power 4 as m power 2 into 2. And again we can write it as m square whole square. Fine. Minus, we can write this 1 as 1 square equals to 0. Then this of a square minus b square form, we can write it as a plus b into a minus b equals to 0. Now equate each factor to 0. M square plus 1 equals to 0. M square minus 1 equals to 0. From m square plus 1 equals to 0, we'll get m square equals to minus 1. Then m equals to plus or minus square root of minus 1, which is equals to plus or minus I. And when m square minus 1 equals to 0, we can just write this 1 as 1 square, and this of a square minus b square form, we can write it as a plus b into a minus b equals to 0. Now again equate each factor to 0. When m plus 1 equals to 0, we'll get m equals to minus 1. And when m minus 1 equals to 0, we'll get m equals to 1. Then m will be minus 1 and 1, right? So we got 1, 2, 3, 4, 4 roots. Then m equals to plus or minus I and minus 1 plus 1, right? Or m equals to minus 1 plus 1 and plus or minus I. Now we got the roots of our auxiliary equation. Here two roots are real and distinct, and we got a pair of complex conjugate roots. Therefore m equals to minus 1 plus or minus I are the roots of our auxiliary equation, which are can write it as two roots say minus 1 and 1 are real and distinct roots, and plus or minus I is a pair of complex conjugate, right? Now coming to the complementary function. When two roots are real and distinct, say m1 and m2 are real and distinct, then yc will be c1, one constant into e power 1 root into x, plus another constant into e power another root into x, right? We know that a plus ib is a complex number, then its conjugate is a minus ib. Likewise, if a minus ib is a complex number, its conjugate will be a plus ib. So we call a plus or minus ib as complex conjugate. When m equals to a plus or minus ib, we can call it as complex conjugate roots. If we have complex conjugate roots, then yc will be e power ax into one constant into, already we have used two constants, right? So I'll take c3 and c4 here. c3 cos bx plus c4 sin bx. In case of a0, if we don't have any real part, then we'll get e power 0 into x, which is equals to e power 0 into x is e power 0 into c3 cos bx plus c4 sin bx. And also we know that e power 0 is 1, then we can write it as 1 into c3 cos bx plus c4 sin bx, and we can write it as 1 into c3 cos bx plus c4 cos bx, c4 sin bx is c3 cos bx plus c4 sin bx, right? Now we are going to use these two formulae to write the complementary function of our problem. Our yc looks like, firstly let's write for the first two distinct roots, okay, real and distinct roots. c1 into e power 1 root into x plus c2 into e power another root into x plus, now let's write for the complex root, okay, pair of complex conjugate otherwise. For b equals to 1, just compare plus or minus I with plus or minus bi. Then for b equals to 1, we'll get c3 cos 1 into x plus c4 sin 1 into x. Then yc becomes c1 e power minus x plus c2 e power x plus c3 cos x plus c4 sin x. So we got the complementary function now. Let's find yp, particular integral. Particular integral. particular integral using 1 by f of d into q. We have f of d and q, where f of d is d's power 4 minus 1 and q is cos x into cos hx. We know that cos hx equals to e power x plus e power minus x by 2. Let's replace cos hx with e power x plus e power minus x by 2, or we can just write it as 1 by 2 into e power x plus e power minus x, since cos hx equals to 1 by 2 into e power x plus e power minus x, then yp becomes 1 by d power 4 minus 1 into cos x into 1 by 2 into e power x plus e power minus x, right? Now let's take the constant 1 by 2 towards left. We'll get 1 by 2 into 1 by d power 4 minus 1 cos x into e power x plus e power minus x. Yp becomes 1 by 2 into 1 by f of d into, just multiply these two terms with cos x, we'll get e power x cos x plus e power minus x cos x. Now we can write yp as 1 by 2 into 1 by f of d into e power x cos x plus 1 by f of d into e power minus x cos x. Okay, we can find each term separately for our convenience. Okay, well, let's find first one, d power 4, 1 by d power 4 into e power x cos x. So this is of 1 by f of d into e power ax into v form. We can shift e power ax towards left by replacing d with d plus a, and later we'll operate v with 1 by f of d plus a, right? Now compare e power x with e power ax, and for a equals to 1, we'll find f of d plus a. Firstly we need to find d plus a. D plus a equals to d plus 1. Now let's shift e power x towards left by replacing this d with d plus 1. Okay? We'll get d plus 1 whole power 4 minus 1 into cos x. Now we need to expand d plus 1 whole power 4. So I'll show you two ways to find d plus 1 whole power 4. We can write d plus 1 whole power 4 as d plus 1 whole square into d plus 1 whole square, which is equals to, we know the expansion of d plus 1 whole square, right? It's easy. D square plus 1 plus 2d. Now multiply these two. We'll get d square into d square plus 1 plus 2d plus 1 into d square plus 1 plus 2d plus 2d into d square plus 1 plus 2d, right? Which is equals to d square into d square, 2 plus 2 is 4, d power 4, plus d square into 1 is d square, plus 2 d square into d power 1, 2 plus 1, 3, so you'll get d cube, plus 1 into d square plus 1 plus 2d is d square plus 1 plus 2d, plus 2d into d square is 2 into d power 1 into d square is 1 plus 2, 3, plus 2d into 1 is 2d, plus 2 2s are 4, d into d square. This equals to d power 4. Now add the terms involving d cube, 4d cube. Okay, now coming to square, we have 1, 2 plus 4, 6d square. Now add 2d, 2d plus 2d, term involving d is 4d, again constant plus 1, right? D power 4 plus 4d cube plus 6d square plus 1. Or we can use Pascal triangle. One, 1 to 1, 1 3 3 1, 1 4 6 4 1, 1 plus 3 4, 3 plus 3 6, 3 plus 1 4 1. Okay. Now we'll break the 1 2 3 4 5 fifth line. Okay. Just write the quotient. Sorry, write the place d's properly. Okay. Here we'll get d power 0, d power 1, d square, d cube, d power 4. So we'll get 1 into d power 4, d power 4 plus here we are having d plus 1 whole power 4, right? So we don't use alternate signs. Just write plus for every term in between two terms. Otherwise, 4d cube plus 6d square plus 4d plus 1, right? You'll get the same thing. Okay, fine. Now coming to the problem, this becomes e power x into 1 by expansion of d plus 1 whole power 4 is d power 4 plus 4d cube plus 6d square plus 4d plus 1 minus 1 into cos x. Here plus 1 minus 1 gets cancelled. Then this becomes e power x into 1 by d power 4 plus 4d cube plus 6d square plus 4d into cos x. We are having 1 by some function of d into cos bx form. We have this term is of 1 by some function of d into cos bx form, right? So here we are going to find d square, which is given by minus of b square. For just compare cos bx with cos x or cos x with cos bx, and for b equals to 1 we'll get minus of 1 square, which is equals to minus 1. So we have to replace d square by minus 1 in the denominator by keeping one thing in mind, that the denominator must be non-zero. What happens if the denominator is 0? We'll get 1 by 0 into cos x. Since 1 by 0 is undefined, so total term becomes undefined, right? So the denominator must be always non-zero. Let's see what happens if we replace d square in the denominator. I'll just take the denominator part. D power 4 plus 4d cube plus 6d square plus 4d. Okay, we can write d power 4 as d square into d square plus 4 into write d cube as d square into d, and remaining two terms will be as it is. Now replace d square with minus 1. We'll get minus 1 into minus 1 plus 4 into minus 1 into d plus 6 into minus 1 plus 4d. Right? This equals to minus 1 into minus 1 is plus 1. Plus into minus minus 4 into d 4d. Plus into minus minus 6 into 1 6 plus 4d. Right? Here minus 4d plus 4d gets cancelled, and this equals to 1 minus 6 is minus 5, which is non-zero. Since by replacing d square in the denominator we got a non-zero number. So what we'll do? We'll just replace d square. Okay. Fine. Now I'll write this as e power x into 1 by, we can write d power 4 as d square into d square plus 4 into write d cube as d square into d plus 6d square plus 4d into cos x. Now we'll replace d square by minus 1. Then this becomes e power x into 1 by d square can be replaced with minus 1. Okay, minus 1 into minus 1 plus 4 into minus 1 into d plus 6 into minus 1 plus 4d into cos x. Right? Is equals to e power x into 1 by minus 1 into minus 1 is plus 1 plus into minus minus 4 into d 4d plus into minus minus 6 into 1 6 plus 4d into cos x. Here plus 4d minus 4d gets cancelled and this becomes e power x into 1 by 1 minus 6 is minus 5 into cos x, or we can write it as e power x into, we can write 1 by minus 5 as minus 1 by 5 into cos x. This equals to 1 by 5 into, minus 1 by 5 into e power x cos x. Therefore, 1 by f of d into e power x cos x is minus 1 by 5 into e power x cos x. Now let's find the second one. 1 by f of d into e power minus x into cos x. And also this of 1 by f of d into e power ax into some v form, right? We'll shift e power ax towards left by replacing d with d plus a, and later we'll operate b with 1 by f of d plus a, right? So compare e power minus x with e power ax, and for a equals to minus 1, we'll find d plus a, which is d minus 1. Now let's replace d with d minus 1 by shifting e power minus x towards left. Shift e power minus x towards left by replacing d with d minus 1. Okay, we'll get d minus 1 whole power 4 minus 1 into cos x. Now we need to expand d minus 1 whole power 4. We can write d minus 1 whole power 4 as d minus 1 whole square into d minus 1 whole square, which is equals to, we know the expansion of d minus 1 whole square using a minus b whole square expansion. We can expand d minus 1 whole square, which is d square plus 1 minus 2d, right? Which is equals to d square into d square plus 1 minus 2d plus 1 into d square plus 1 minus 2d minus 2d into d square plus 1 minus 2d, which is equals to d square into d square is d power 4 plus d square into 1 is d square minus 2 into d square into d is d cube plus 1 into d square plus 1 minus 2d is d square plus 1 minus 2d minus 2d into d square is 2d cube minus into plus minus 2d into 1 is 2d minus into minus plus 2 2s are 4 d into d square, right? Then expansion of d minus 1 whole power 4 will be d power 4. Now look at the terms involving d cube. We have minus 2d cube and minus 2d cube, which is minus 4d cube. Now write the terms involving d square, 2d square plus 4d square is 6d square. Now terms involving d, minus 2d is minus 4d. Now constants 1, right? Or we can write using Pascal triangle. 1 1 1 1 2 1 1 plus 1 2 1 1 1 plus 2 3 2 plus 1 3 1 1 1 plus 3 4 3 plus 3 6 3 plus 1 4 1, right? Now we'll choose the fifth line. 1, 2, 3, 4, 5. Fifth line. To write the expansion of d minus 1 whole power 4. Here let's choose the fifth line. Here we are asked to find the expansion of d minus 1 whole power 4, right? We have minus, so let's choose signs, alternative signs. Okay, we'll place signs alternatively and place d's properly. D power 0, d power 1, d square, d cube, d power 4. 1 into d power 4 is d power 4. Minus 4 into d cube is minus 4d cube plus 6d square minus 4d plus 1. Right? We'll get the same thing. Now coming to the problem. This becomes e power minus x into 1 by expansion of d minus 1 whole power 4 is d power 4 minus 4d cube plus 6d square minus 4d plus 1 minus 1 into cos x. Here plus 1 minus 1 gets cancelled and we'll get e power minus x into 1 by d power 4 minus 4d cube plus 6d square minus 4d, right, into cos x. And this is of 1 by some function of d into cos bx form. Right. Compare cos x with cos bx, then for b equals to 1, we'll find d square, which is given by minus of b square, which is equals to minus of 1 square, is minus 1. Now let's see what happens if we replace d square in the denominator. Always remember that the denominator must be non-zero. If the denominator becomes 0, we'll get, or the term becomes 1 by 0 into cos x. Since 1 by 0 is undefined, so total term becomes undefined, right? So let's see what happens if we replace d square in the denominator. We'll write d power 4 as, I'll just take the denominator part. You can write d square, d power 4 as d square into d square minus 4 into d cube can be written as d square into d plus 6d square minus 4d. Now replace d square with minus 1, we'll get minus 1 into minus 1 minus 4 into minus 1 into d plus 6 into minus 1 minus 4d, right, which is equals to minus 1 into minus 1 is plus 1, minus into minus plus 4d, plus into minus, minus 6 into 1, 6, minus 40. Here plus 40 minus 40 gets cancelled and we'll get 1 minus 6 is minus 5, which is non-zero. Okay. By replacing d square by minus 1, we got the denominator non-zero, or the denominator is non-zero by replacing d square with minus 1. So we can replace d square with minus 1, right? Now this becomes, we can write the denominator, d power 4 as d square into d square minus 4 into, write d cube as d square into d plus 6 into d square minus 4d into cos x. Now replace d square by minus 1. We'll get e power minus x into 1 by minus 1 into minus 1 minus 4 into minus 1 into d plus 6 into minus 1 minus 4d into cos x. We just replace d square by minus 1 here. This is equals to e power minus x into 1 by minus 1 into 1, minus 1 is plus 1, minus 4 into minus 1 is plus 4 into d4d, plus 6 into minus 1 is minus 6, minus 4d into cos x. Here plus 4d minus 4d gets cancelled. This becomes e power minus x into 1 by 1 minus 6 is minus 5, right? We'll get 1 by minus 5 into cos x. We can write 1 by minus 5 as minus 1 by 5. And this becomes minus 1 by 5 into e power minus x into cos x. Right? So, therefore, 1 by d power 4 minus 1 into e power minus x cos x equals to minus 1 by 5 e power minus x cos x. Now coming to yp. Result obtained from the first term is minus 1 by 5 e power x cos x, and result obtained from the second term is minus 1 by 5 e power minus x cos x. So here minus 1 by 5 and cos x exists in both the terms. So let's take minus 1 by 5 and cos x common from these two terms. We'll get minus 1 by 5 into e power x plus e power minus x into cos x, right? Again, we can write this as 1 by 5 minus 1 by 5 into 1 by 2 into e power x plus e power minus x into cos x, right? This is equals to minus 1 by 5 into, I'll write 1 by 2 into e power x plus e power minus x as e power x plus e power minus x by 2 into cos x, since we know that e power x plus e power minus x by 2 is cos hx. Since cos hx equals to e power x plus e power minus x by 2. So now let's replace this term with cos hx. Then yp becomes minus 1 by 5 into cos hx into cos x, or yp equals to minus 1 by 5 into cos x into cos hx. We got yc and yp, so now let's write the general solution. Therefore, the general solution is given by y equals to yc plus yp. Then our solution will be y equals to yc, c1 e power minus x plus c2 e power x plus c3 cos x plus c4 sin x plus yp. Yp is minus 1 by 5 into cos x into cos hx. So this completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.